Professor Hennessy told me that a lot of his Stony Brook graduate classmates went to work at Bell Labs and other industrial research organizations on the East Coast. Almost all of those are gone. There's no more AT&T Bell Labs. IBM has cut back their research, as have almost all the major companies. The US has, as a result, fallen behind other countries in innovative technologies and in design, development, and manufacturing of real things, not software for gadgets or e-commerce or Facebook, Twitter, etc., but making real things. Today, most high-tech manufacturing is done offshore, mostly in Asia. Almost all of the smartphones and tablets are made in 3 places: China, Taiwan, or South Korea. And even Apple, one of the leaders in this field, outsources the design and a lot of the development of their smartphone tablets to those Asian countries. What will it take for the US to regain our innovative technology edge and global competitiveness in the engineering of new products and in high-tech manufacturing?
So this is a complicated problem. I think the manufacturing, let's take the manufacturing piece, it's the easiest piece to peel off. We missed the boat. Quite simply, we missed the boat. What happened was there was a transition time from semi-skilled or unskilled manufacturing, which is largely what the US had until 20 or 30 years ago, when even that was vaporized by labor arbitrage. We missed the boat in a shift to skilled manufacturing, which requires more than a high school degree, which requires either 2-year degrees or 4-year degrees, which requires a level of sophistication in technology and mathematics that, by and large, our manufacturing workforce did not have. We never made this a serious concern. It is a serious concern in other parts of the world. It's a major focus. It's the place that's really won out and managed to do this is Germany. Germany's done it by having a very strong vocational education system that takes students who are bound for that track, educates them very deeply about manufacturing, puts them in internships, gets them working with companies, and really makes an effort to make it work. We never had that, so our educational system isn't doing it. Our community colleges are struggling, but they don't really do it, and partly it's partly a problem about our K-12 system. Our K-12 system, at the high end, it's fine. We produce kids who can go on to be math and science majors. But we don't produce a lot of young people who have enough capability in math and science to go into a 2-year manufacturing-intensive focused program. They just don't have the background coming out of high school to do it. So if we're serious about this, we're going to have to fix those issues first and begin to think about it. I remember a number of years ago, I went to the plant in China, in Shenzhen, where the iPhone is manufactured. And we were looking at that manufacturing line. That manufacturing line runs 24 hours a day. There are QA engineers. So these are people with 4-year engineering degrees, but it's an engineering degree focused on quality assurance and manufacturing, something which there are only a very few places in the US that even offer them. And they worked all 3 shifts. So they had engineering people working the graveyard shift, right? Now, engineers in the US work long shifts, but there are very few of them that are assigned from the midnight to 8 a.m. shift, right? If we're really serious, we've got to prepare for that kind of commitment to that. I think the design, when we start talking about design and the design of products, we get into a much trickier region. Perhaps to believe that we were going to continue to be not only the technical leader in the world, but the technically dominant force, when in fact only a small fraction of the world's population is in the United States, was somewhat foolhardy, and we see some of that. We see some of that changing now. A lot of core technologies still are designed in the U.S., and we've seen the rise of the so-called ODMs. The ODMs are not doing high-end manufacturing or high-end design, but they're doing a kind of design where the fact that they pay engineers a third to a half what they get in the U.S. Turns out to be particularly useful. For us, I think, as Tom Friedman said in a column, there's only one way to address the ongoing competitiveness challenge, and that's to educate your students better and run faster. I don't think there's any other solution that will work.
Thank you, John. Just a comment on that for those who didn't catch the acronym. ODM is Original Design Manufacturers. They're primarily based in Taiwan and elsewhere in Asia, and they make products such as, quote, bare metal switches, unquote, that is threatening to Cisco Systems and other vendors of networking and data center equipment. Along those lines, what do you think of these bare metal switches supplanting legacy vendors in data centers and in networks and in computer rooms?
So I think any of these things, bare metal switches, white boxes, sometimes called. The thing about the computer industry is very few companies in the IT industry survive from one generation of technology to the next. They certainly rarely dominate. Even companies that have been very successful have a hard time moving from one generation to the next. And you can look around the valley. There's lots of them, even in companies that still survive. I mean, and the reason is that the new young upstarts, whether they be in hardware, for example, or in software, come with a completely different mindset, right? And if you're Microsoft and you dominate in the PC enterprise space, and somebody comes along and invents the internet, and it means a whole new way of thinking about software and cloud computing and client server and things. Boy, the architecture you have and what made you very successful are not the skill sets and the background that make you successful in that next revolution. And we've seen this time and time again. Companies thrive when they learn how to continue that innovative thing. When they obsolete their own products instead of letting other people obsolete them. It's a very hard thing to do, though, to bring out a new product and obsolete your existing product line, particularly when that product line has high gross margins and is making you a lot of money.
Isn't that something that Cisco has to do now,
yeah,
for example?
Cisco has to do it.
As you know, John is on the board of Cisco.
Look at Digital Equipment Corporation. It was a company, a great company, incredible. Second best, second largest computer company in the world, and engineers that were at least as good as anybody had. And they basically didn't face the future, and they had these great VAX computers they sold for, and new technology got invented based on microprocessors, and you could build machines that were the same performance and cost 1/5 the price. This is not a recipe for being successful going forward. So you've got to obsolete your own products. You have to do it. And then, figuring out how to do that, what happens to gross margins, how do you get the company to thrive, how do you make a value proposition, you've got to get all those things figured out.
We could actually
I don't think they're easy. They're hard problems.
We could actually have a whole conference on this subject with Professor Hennessy being one of the panelists. But let's move on in the interest of time.